Hey everyone, and welcome to this explainer. Building a smart robot helper today is actually surprisingly easy. You can write a little code, connect it to the internet, and have a super cool demo running in literally minutes. It feels kind of like magic. But here's the secret that developers are finding out the hard way right now. Making that exact same AI do absolutely everything, that is a recipe for a total disaster.
So what actually happens when one single AI tries to take on the whole world? Well, think about it like this. Imagine you're the only kid trying to do a massive group project for 5 different subjects, all by yourself. You're doing the writing, the drawing, the math, the presentation. You'd go absolutely crazy, right? The quality would drop, and eventually, you'd probably just freeze up. Well, believe it or not, artificial intelligence acts the exact same way.
Okay, let's really dive into this. When we ask an AI to do a quick, simple demo, it looks like an absolute genius. It just knocks it out of the park. But when we push that exact same AI to handle massive tasks, leaving it totally alone to figure out a million steps by itself, we don't just get a tired AI, we get a system that completely burns out and breaks down. Just piling on more work ruins the whole shebang.
Section 1. One very smart helper. Let's peek inside the AI brain.
To really grasp why this burnout happens, we kind of need to understand how these bots operate when we give them a simple, narrowly scoped task. Most AI agents follow a super simple 4-step loop. Step 1, they make a plan. Step 2, they act, using digital tools to search the web or do some math. Step 3, they remember, storing what just happened in their memory bank. And Step 4, they reflect on what worked and what didn't. When the task is small, this 4-step loop works like absolute magic. The AI makes a few quick choices, finishes the job, and stops. Super easy.
Section 2. When tiny mistakes grow big. The problem of failure propagation.
All right, put on your detective hats, because we're going to investigate an epic AI failure that happens when we try to take that simple loop and scale it up to do way too much at once. Imagine you tell your shiny, super smart AI travel agent, book me a trip to Washington. Simple enough, right? The AI gets right to work. It follows its loop perfectly. It finds flights, it books hotels, it even sets up a rental car. A few minutes later, your trip is fully planned, organized, and ready to go.
But there is a huge twist in our mystery. The AI booked your flights and hotels for Washington State instead of Washington, D.C. You wanted to go visit the Capitol, see the monuments, maybe check out the White House, but your solo AI just sent you nearly 3,000 miles away to the total opposite side of the country. No way, right?
And this right here perfectly illustrates the domino effect. The AI didn't just make one silly little mistake that we could quickly fix. Because it made one tiny wrong assumption at the very beginning, misinterpreting the word Washington, that one error poisoned the entire plan. It influenced the flights, the hotels, the rental cars, literally everything. In computer science, there's actually a fancy name for this. It's called failure propagation. The AI wasted tons of time and money, and since it was working all by itself, it didn't even know it was messing up.
Section 3. The trouble with too much. The real cost of scaling up.
Let's talk about the actual science behind why our smart helper completely loses the plot when we give it too much to do. If you chart this out, the brain energy an AI needs just completely explodes upward as the task gets bigger. It's not a straight, predictable line. A task that's twice as big might literally take 10 times as much effort and brain power to pull off.
So what's actually happening inside the computer when you push one AI too hard? Well, first, you get brain drain. The AI is working so incredibly hard trying to process everything that the computing costs just skyrocket. Second, you get slowdowns. It takes forever for the AI to just make a simple choice. And third, there is way too much clutter. The AI has to dig through its own massive, noisy memory just to figure out what to do next. It's like trying to find one specific Lego piece in a room filled with a million unorganized toys. A total nightmare.
It is exactly like one person trying to play every single instrument in a giant orchestra at the exact same time. You wouldn't expect one guy to play the drums, the violin, the flute, and the trumpet all at once, would you? The bottleneck here isn't that the AI isn't smart enough, it's that having one centralized person trying to do the engineering, the marketing, the hiring, and the support all at once is ridiculously expensive, slow, and totally fragile. Section 4. Teamwork to the rescue. Enter multi-agent systems.
So, how do we actually fix this giant mess? If one person can't play the whole orchestra, what do? Well, you form a band. The answer is multi-agent systems. Instead of one overwhelmed superbrain, you create a team of specialized AI agents. Each agent has a very specific, small job, and they work together to complete the mission. By breaking the massive project into smaller pieces, each individual decision becomes cheaper to run, much faster to process, and honestly, way easier for you to manage.
Comparing the two approaches really highlights the difference. A single agent trying to juggle it all is noisy, expensive, and fragile. If it drops even one ball, the whole juggling act totally fails. But a multi-agent team, it's focused, it's fast, and most importantly, the failures are contained. If the flight booking agent gets confused about Washington, the totally separate hotel booking agent might catch the error, or at least ask a clarifying question. Teamwork actually stops that domino effect from destroying your whole project.
Section 5. Building your AI team. Making the big architecture choices.
Now that we know teamwork is absolutely the best way to get things done, how do you, as the big boss, the system architect, actually design this super team of agents? When you're building out your system, you basically have two main choices for growing your team. You can scale horizontally, which means hiring a totally new, separate expert agent. Think of this like adding a dedicated fact checker to your group project. Or you can scale vertically, which means teaching an old agent new tricks, like giving your existing research agent a cool new search filter tool so it can do its own job just a little bit better.
So, how do you choose? Well, here is the golden rule from the experts. You want to split tasks horizontally into new agents if the jobs are totally independent and reusable. But you embed tasks vertically into existing agents if they use the exact same information and background knowledge. Adding more agents horizontally means they have to spend time talking and coordinating with each other, while scaling vertically makes that single agent's brain a little more crowded and complex. So the crucial point here is you have to choose where the complexity lives. Building a big, scalable system is always going to bring challenges. But as the system designer, you get the power to decide. Do you want the hard work to happen in the communication and coordination between your team of agents, or do you want the hard work to happen inside the brains of the individual agents themselves?
I absolutely love this quote from the experts. It sounds a bit fancy, saying that intelligence compounds instead of collapsing. But what that really means is that the smartest, best-designed system will beat the single smartest individual agent every single time. It's all about designing a team where the limits are clear, the costs make sense, and the teamwork builds up to something truly brilliant. So, I'm going to leave you with this final thought. What kind of AI team will you build? Are you going to rely on one totally overwhelmed robot trying to do it all? Or will you think like a true system architect and build an unstoppable team of specialized agents? The future isn't just about making smarter bots, guys. It's about getting them to work together. Thanks for joining me on this explainer, and I really hope you're feeling inspired to dive in and design some amazing systems of your own.